not that different. However, what you've experienced is it's not fixed like that. Okay. Yes. Well, you can, there's been quite a lot of studies mapping. So, for example, violinists, their fingering hand has a much bigger map. So the left hand, so the right finger area, thumb and, well, not so much thumb, it's the fingers, it's much bigger. Sometimes it's bigger. What the difference is often is that when they're the more differentiated. So the area that's first finger, second finger, third finger, fourth finger are very differentiated for a violinist on their left hand compared to the right hand, where there's a bit more smudging between the borders of the fingers. Yep, could be. Yep. So it's functionally dependent. Yep. There have been a couple of studies that have shown that people with chronic low back pain, their back gets bigger with the pain in this S1, but that's not a consistent finding. They usually do, yeah. Genitals. Otherwise not. No. The penis is quite small in the woman. So in the female sensory homunculus, the labia are really big. Yep. Okay, so as I've said, this identity, this image is a construct. So it's clear we have representational spaces in our brain to construct our body image using both inputs, so the sensing, and the outputs, the action. So the more you use it, the actions shape this image, the outputs and the inputs shape this image. So it's more than that though. So we have these emotions and judgments about our body that are quiet and modulated. So we've talked about this affect, how we feel about our body, and it modulates in time and space. So the next slide is the way we link these things. There's a structure called the thalamus. There's one on each side, and it's like Grand Central Station. So pretty much every sensation coming up from the body that then gets dispersed firstly to S1 and then to the association areas goes through the thalamus. All sorts of everything, and then movement instructions also go through the thalamus. So that's why it's sort of a Grand Central Station. It's like there's a lot of convergence, motor and sensory, in the thalamus. In there, inside. So the one in there, one in there. So they're it's kind of a ball, sort of a like a UFO shaped thing in either side. Hypothalamus is underneath it because hypo means below. Yep. And the thalamus was a bit victimized years ago around chronic pain. We used to call it thalamic pain, but now it's sort of centralized because you can't blame the thalamus for it. It's been rehabilitated, and we can do a thalamectomy, which would be a disgusting thing to do, and you'd still have pain. However, it is quite a site where these things can come together, this ultimate relay station, and the emotional aspects of it. So it's got an aspect of it's also part of the autonomic nervous system in a sense. Now, you probably heard about the limbic system, which is that kind of, there's a whole lot of structures in the limbic system that sits deep within, right in the middle of the brain, and it's also both sides. There's a thing called the amygdala, which you might have heard of, which gives an affective or emotional connotation to experience, amongst other structures. The hippocampus, which holds experience, is very involved in memory. There's been a lot of experiments around different parts of the hippocampus for different kinds of memories, particularly spatial memory. The hippocampus was one of those areas that they mapped quite a lot, with the taxi drivers, the London cabbies who've got the knowledge. And when they first started getting really good at imaging these deep brain structures, they noticed that London cabbies, before they got do you know what I mean by the knowledge? So London cabbies, to get their ticket as a London cabbie for the black cabs, they had to be able to pass this test called the knowledge, where they had to be able, they didn't need, this is obviously pre-street directories, pre-everything, that they could find, they knew every street in London. So they had this incredible spatial memory for all the streets of London. So it's clearly before GPS. And these guys had this particular part of the hippocampus was much bigger than in the cabbies who didn't have the knowledge. And so the process of acquiring the knowledge, so that's when it became very clear that the hippocampus is really important for memory, and particularly the aspect of the hippocampus for spatial memory, which is spatial memory is a multimodal coded thing too, so visual, but probably somatosensory as well because of the directionality of it, etc. Oh, yeah, that thing about men are better at, yeah, sort of, but it's very hard to tease out how much that's cultural and exposure. So I'm actually really good at reading maps. My spatial memory is really good. So there has been a suggestion that men are better at spatial memory, but they're starting to unpick it because there was a bit of a thing about, the spatial memory stuff often goes with maths. And girls can be just as good at maths, but there's all this cultural shit about not doing maths. There's a really good book called Spirit Level about girls meet the expectation about not being good at maths, and how we meet expectations. Whereas so they've done all these tests where they've said, they've given a test to girls and show how that they're very susceptible to this. So a maths test, and if they say at the beginning of it, it's an easy maths test, you'll be fine, they do really well at it. Same test given, and they say, girls find this really hard, it's do your best, they do really badly at it, same test. And boys aren't as suggestible to that. So, there's a lot of weird shit happens with sexual, the gender side of things. And of course it's a bell curve, so the overlap between the male, female, there's more overlap. We're more similar. It's only when you get to the tails that there can be these extremes, sort of. Okay, so hippocampus you probably heard about. So that's experiences, former memories. The anterior cingulate, so that's more to the front, and the insula, again, are a connection point between the autonomic interoceptive kind of thing. So sensing, gut senses and sensing your heart and sensing your respiration rate and all that sort of stuff, and emotions. They're a big overlap in those structures. When I say overlap, actually those structures just, they organize those things. The brain doesn't see a bit of a, difference, really. And then the hypothalamus, which you mentioned, which is a lot even more autonomic stuff around regulating hormones and regulating, the sort of hormones and the neurotransmitters, same thing. But the hormones for the body, neurotransmitters for the brain in part, regulated by hypothalamus. But it's also very associated with emotions and memory. So it's like you could come away from this thinking, God, everything does everything. Well, in a way it kind of does. Like we talk about these systems like they're different, like emotions and memory and interoceptive and this and that, like they're different things. And it's just not like that in the brain. Sorry? Need a new word. Yeah. Feldenkrais. No, not Feldenkrais. We've separated these things out functionally, like emotions and memory and this and autonomic stuff. But from an organizational point of view, they're very interconnected. That's my point. And then the prefrontal lobes, there's a lot of emotional stuff happening there. So in the sort of just above the eyes, you probably heard about the inferior orbital sort of areas. I don't know what's on the next slide. There's thought to be a bit more. There's a bit of a thing about, I think it's the left inferior part in the frontal lobes here, just sort of in behind here, is more towards the depressive and the other's more towards the uplifted or something like that. So there was some experiments about people doing that happiness training, and they'd get less activity on the left side and more activity on the right side in that area, and vice versa. That's early days for that kind of investigation. But we had this weird thing. My sister-in-law had this massive meningioma, and I can't remember. That was was the dip on the left side, I think. Anyway, whichever side is meant to be more sort of depressive. I can't remember lefts and rights, as you know. Anyway, she was getting more and more morose. Nobody knew she had the meningioma. She actually became averbal. I shouldn't talk about my family, should I? But anyway, you won't never meet her. She's not a happy, flamboyant person anyway. But she was really getting even more dour, like, ugh. And she just stopped talking. And they finally bundled her to a doctor and had a CT scan. She had this big meningioma that was very slow growing, so it's benign, but just pushing right into that part of her brain. She had it removed. She was so happy. Like immediately after, it's like this. It was a bit of a change of personality. She was happy and loving, and it was a very sad thing, actually. She sort of kind of calibrated back to being her usual sort of vaguely Germanic self. But my mum just kept on waiting. It's a new girl. It's a new girl. I mean, she's not a girl. She's in her 50s. So, it's an amazing thing, the brain, isn't it? Sorry? I actually don't, but I grew up in an area with a lot of Germanic. No, we're English, Irish, French, Scottish. But I learnt German because I grew up with all these Germans, and we studied German together. Yeah. Do I? Without even knowing it. Yeah. Well, I grew up in the Barossa Valley. What more can I say? Shiraz. Yeah. When I went out for dinner with my colleague, this guy tried to, say, this great Shiraz from the Pyrenees. And I went, oh, French. And apparently there's Pyrenees in Victoria. I went, you don't make Shiraz in Victoria, do you? That's so rude. Anyway, back to here. Everything seems to, when I say everything seems to be involved in creating this image, it's hard put to find somewhere that's not involved. So it's extremely complex. So your point, Nina, about what's identity, it's pretty hard to say what it's not, What's next? Is that it? No. So I've talked a little bit about connectivity. So it's important to think about the brain now in terms, I mentioned this right at the beginning of this week, about these isolated regions is not necessarily a helpful way to think about the brain anymore. When all we could do was zap the brain, that was the kind of representation that we got. Now that we can look at it and actually map the strength of the pathways between, it seems that the biggest predictor of good function is the connectivity. When connectivity improves, function seems to improve, rather than areas getting bigger or less. It's sort of a simplistic way to look at things. So these areas, oh sorry, can I just go back to, I can't remember what I said with that thing. These areas have to talk to each other to produce this integrated, potent, complete, actualized, owned, and understood image. So those words are all chosen deliberately because they're all features of this image, and reflected by pathways, and where there are very, sort of small pathways between areas. There could be roads, there could be freeways, and then super motorways. And when we are strengthening these pathways through experience, that's what we're doing in ATM, is you're making a connection. It could be a very tenuous connection, between you, in terms of sensing your connection to the ground. However, you keep strengthening that connection through practice and attention. Okay, so the next slide is, these are my beautiful pictures about connectivity. So the picture on the right is the brain from the side, and the picture on the left is the brain from the top. And we've got the codes there. So these are the connectivity maps that are being produced by the brain. So this is a amalgamation of a whole bunch of different functions, but they can map them for specific functions. So the green, any greeny kind of colour is a tract or a connection going from front to back. Red is a connection going from right to left, and blue is generally a connection going from top to bottom. So this is my argument for why we're not a hierarchical structure. Because if it was a hierarchical structure, we'd have a lot of connectivity going top to bottom. We'd have a lot of blue. You can see that no one, there in certain regions, colours can dominate. What you might see very carefully, if you look at the one on the left, see a lot of horizontal red right in the middle. That's the corpus callosum. So the amount of connectivity between the right and the left hemisphere is huge. So this idea that we are more left hemisphere or right hemisphere is not an accurate view. We have specializations in each hemisphere. So speech and language is more in the left hemisphere. However, we need the right hemisphere for other aspects of speech and language. So prosody, so the sort of timing of speech, the musicality and the spatial aspect of speech is in the right hemisphere, for example. So people who have a right hemisphere lesion, their speech is still affected. Because spatial stuff tends to be more right hemisphere, there was that whole thing about drawing on the right side of the brain. You need your left side as well. Now, you can have a corpus callosectomy, and the brain still communicates because there's other tracks. And then those people, it's the split brain experiments. You might have heard about. They used to do it in the 70s and 80s for people who had really horrible epilepsy. When they couldn't control it by drugs, they would actually, to keep the epilepsy in one hemisphere, they would split the corpus callosum. Those people still functioned really well, but they couldn't do weird things like now let me get my lefts and rights mixed up. If they put their hand in their pocket and felt something with their right hand, it was okay because that goes to the left hemisphere and they could name it. But if they felt something in their pocket with their left hand, so they didn't see it, and it goes to the right hemisphere, that information wouldn't get transferred over, so they couldn't name it. So they do weird things like that. Yeah. You want the box?
How do you explain this? So I had a friend whose second child was right-sided hemiplegic. And for his 21st birthday, he showed me his brain scan, or a brain scan, and he only had half a brain.
Yeah.
And
he's one of those. You've met one of these people.
Yeah, he only had half a brain, but he had epilepsy as well.
Yeah.
But he could speak.
Yeah.
I mean, I can imagine if he'd had a full brain, he would have been amazing. I mean, brilliant. Yeah. So he could ride a bicycle, and speak. He was pretty much functional. And he wasn't allowed to drive because he was epileptic.
Yeah. So these kids that grow up with half a brain I use those stories a lot, and because I work with neurologists who like neuroplasticity is like, what? Oh, it's hocus pocus. It's like, oh, you've got to be kidding. But my favourite neurologist, he uses those examples of kids to try and get his colleagues to realise about the brain's potential. I mean, I've worked with neurologists there was a neurologist years ago whose wife had a stroke, and he just wouldn't even let her do rehab because he didn't believe in it. Like, I cannot tell you the Philistine attitudes out there. So my dear friend, a younger neurologist, he's got pictures of these folk, and I've never met anybody who's literally had and under extraordinary conditions, these kids can grow up almost normal, like with almost no neurological deficit. This other he has. Yeah. And then they do a brain scan and think, oh my God, he's got, only got one hemisphere. So these are the stories of the most extraordinary brain plasticity, where other parts of the brain pick up those functions. And that's how they explain it. And Tim uses that story all the time. Or they've found kids who are neurologically intact, and they have a brain scan, and their ventricles are huge, and they've just got this kind of thin rim of cortex and all these structures inside that we think are vital, but they've somehow used all redundant circuits and that functional reorganisation I talked about to operate functionally. Now, the big question for me is, how come that kid did that and another kid will have a little tiny, almost imperceptible lesion of a cerebral palsy? Is extraordinary. I work with extraordinary parents too.
Yeah, but I don't like that theory so much. Then we can all blame ourselves.
Yeah.
No,
There's something else. There's something else. Yeah. 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 It can't be all that, because I work with parents who never stop working with their children, and they are very disabled kids. And that's the $64 million question that none of us can answer. Why? Why is it different? Yeah. Right. It's extraordinary. Yeah. And why him? And, I work with people who've got very diffuse axonal imagery. It doesn't even show up on imaging. You image their brain and their brain looks normal. And they are. So, there's just so much more to learn. So whatever I'm telling you today, maybe we'll have answers for this in 5 years, 10 years. We don't know, but there is still so much more to learn. So this is the next kind of thing. Yeah. The box.
Our sort of family doctor, he showed us that example too,
Yep.
of that man, and he was just really in awe and wonder about it. And he's one of these interesting dudes, like just his personality. I don't know what it is, but he's an odd guy, but
Yep.
he's a really beautiful guy and really intelligent, and a doctor and all that. And he just sort of tries to bridge alternate therapy and normal doctor sort of stuff.
Yep.
And he was talking about these studies that are coming out now, that there's still not much, but there's really persuasive sort of evidence that our hearts actually have sort of brain tissues or sensory something. I'm probably not saying it right, but
yeah, you can tell by my face. I'm not a fan of thinking about the part of the nervous system that's in the viscera, so the heart and the gut, as being a thinking brain.
Mm-hmm.
It's helpful to think about the nervous system and the whole of the body being very integrated, and that they influence each other. Yeah. Like the gut. Now, people will say, I think with my gut. You don't. You don't think with your gut. You're sensing it with your gut. You can associate feelings and you can interpret stuff with your gut. You relate to your gut. But the cognitive stuff, thinking isn't there.
Yeah, it's quite conceptual breaking in a way. And also with like the cultures thing about the Tibetans, like when they'll say like, heart or and they'll put their hand on there. They'd say brain, sorry, my mind.
Yeah, is in your heart. Hand. Yeah.
But that's, I guess, mind, brain.
Yeah, I think we're not going to, talking about where the mind is a whole nother question.
Yeah.
Because the mind is an emergent thing that clearly does not reside in any one area, in any part of the body. So we're not going to talk about the mind.
Just sort of.
Because we don't know. Like, that's the point, is we don't know. All we can say is the mind emerges from this interaction of all of the systems, most of the systems, not all of them. And when it's snuffed, it's snuffed. You know, when someone's brain dead, they don't have a mind as such. You know, that we can keep the rest of their body beating and their heart beating and this, that, and the other. But without this interaction of the nervous system and the body, the mind can disappear and the person can be alive. Anyway, So sorry,
sorry.
It's not helpful. I just don't think that when we say metaphorically, we're thinking with our gut. We are paying attention to. Remember, I said we can experience and interpret emotions from what we sense in our gut. It's not to say that the thinking and the thinking around that resides in the gut. It's we express our emotions or we experience our emotions in some of our more vegetative organs because they are very rich in receptors, and particularly that autonomic system manifests activity that we experience in our gut. If that makes sense.
Yeah.
So I'm just thinking about the brain, the half-brain person or whatever it is. I mean, if we're looking at the impact of environment and society and being persistent, if you are going to make the kinds of changes through Feldenkrais practice that you're looking at, are you persistent to the point where you do it every day, or
with the kids that I work with?
Does it make any difference?
Yeah, we don't know. Okay. So we're trying to get evidence about the effect of Feldenkrais, and one of the students from the other training program is currently battling with NDIS for her little boy who's got some kind of disability. I can't remember what, because NDIS are getting tricksy about what they'll pay for. And she was asking me if there's any evidence for the impact of Feldenkrais on children, for example. No one's done the studies because it's bloody hard. Chava Shalav, her PhD, was doing it, but I haven't, to be honest, I haven't read it. So there are some things, but they're not well-designed studies to show what the level of effect is, except for one on bruxism with children, like teeth grinding. There was an RCT on that showed that it was effective. Very helpful. So we are stuck for the hard evidence, and nobody wants to fund it because RCTs are expensive and I can only do what I can do on the cheap. So we're still emerging. What do we do? What do we say to parents about how much to do? My big thing, and the practitioners in the room is I work a lot with the parents with children with Feldenkrais. And I think I was saying to Jenny the other day, I've got two little boys on my books that I see. One is once a fortnight, one's once a month. And I, in a way, feel almost redundant now because I watch the way the parents work with these boys all the time. And they are basically giving lessons all the time. When they're putting on their nappies, when they're putting in their tube, when they're doing this and that, their handling and their facilitation and giving the child the opportunity to sit. That's the biggest thing. If you ask them what have they learned from me, that's what they've learned, is that there is no opportunity wasted. I mean, if it's in the middle of the night, they're going to get the lifter out, whatever, do something. However, other times, instead of just picking the child up from lying and carrying them like this, they take them through side lying so the boys get a chance to push up and do this and do this and do this. So therefore, our aim is for this kind of facilitation approach to become part of the parents. So it's in the environment all the time. That's my view. This little funny slide could be a brain map for a particular function, like let's say remembering, let's say driving to the shops. It could be mapping that function. However, it's not. I think it's a Twitter account, something like that. But interestingly, this is the way we think that the brain works, is there are these sort of nodes of activity, And it's the degrees of connectivity between the nodes that will dictate whether it's this function or that function, which is why, therefore, you could say the hypothalamus is good for emotions and autonomic, because it's what it connects with. It's not the function in itself in that region, but what it connects to that predicts the function, if that makes sense. So you can see that Larry is well connected. So he's got 1, 2, 3, 4, 5, 6, 7 different nodes that he connects with. So he's got a high degree of centrality. So he's quite influential, and he probably is something like the hypothalamus. And Linda is also quite well connected. So she has a high degree of connectivity and a high degree of influence. Felicia should be joyous, obviously fires up on one particular function, let's say. So it's just one way of looking at this non-hierarchical way that the brain networks for any one function. So if you took out, some of these people, similar areas could be involved in quite a different function. Okay, what's next?
All the examples of marvelous recovery that I've heard of,
Yeah.
The patient all the examples of marvellous recovery that I've read about, the person is really involved and really prepared to put in the big ones.
Yeah.
And that's something that we're probably going to struggle with, is we might be doing a class or trying to work with someone and they don't want to know about it.
Yeah.
They're willing to come along, they're enjoying the company, they're enjoying whatever, but they're not looking forward to integrating greater movement.
Yeah.
And that's when I started thinking about the children. Maybe the children had a subconscious thing they've inherited that they're not going to change.
Or that part of like one of those centrality nodes could be around engagement and attention and motivation. And if the kid, let's say that part of the brain, those nodes that are to do with that specific aspect, if that's the area that's damaged or not there, then that might predict it as well. So your point is absolutely spot on, is that the level of engagement and motivation, and therefore use, is critical. And so if you have people who aren't that engaged, then the changes will inevitably be less. Now, you can get kids to engage not at a very conscious level through games and fun. So they don't know that you've got an intention about, head control. So the little boys that I work with, neither of them they can't keep their head on the, straight yet. They're not interested in doing very prescribed kind of lessons around head control. They'll only do it if it's fun. And one of them, if he's got the iPhone there with his favourite music on, he's got head control. If it's not there, he's not got head control. Mm-hmm. So it's all about engagement and motivation.
More Feldicons.
And Feldicons. And how you get people to engage with you. Now then, therefore, does this work with people with dementia? Maybe. It's harder. I won't kid you. It's harder because they're not going to get... Yeah, that's right. Yeah. Lynn's got a great video of when she was working with kids with ADHD, I think. She just makes it fun and keeps the movements big, So it's a very crucial aspect. This picture is the way the brain is not organised. So this is where there is a leader and there are followers. And you will not see this kind of connectivity pattern in the brain. Soren used to tease me and say, well, who's the boss in the brain? I go, there is no boss, because I am, the ultimate non-hierarchical person. I hate hierarchies and I hate bosses. Don't tell my boss that. One day when I had one of my appraisals, I'm not very good at managing up because I don't deal well with hierarchies. So I don't like that connectivity pattern, and it doesn't exist in the brain. Full stop. So it's a leaders and a followers map. It certainly exists in universities. This is another kind of way of mapping the brain. This is also Twitter. It's called a world map for obvious reasons. And they can actually now map. So if you think about all the name, and this because it's a Twitter thing, all the names on the outside are people, and you can show different levels of connectivity. But they've actually mapped brain regions like this. So they around the circle are all different parts of the brain. And when someone has dementia, for example, the map changes radically because there is a lot less connectivity between some areas, and they really start overusing other areas, a bit like there's obviously a lot of stuff happening in a few areas there. And there's even like the map, Parkinson's, and how they have to, because, the basal ganglia is not, and that's quite a central node of activity, how they have to use other areas. So other areas have to start lighting up. So this is where it's going, and they do all this kind of modelling around brain activity like this. Is it a mind fuck? Probably, but I quite like it. It's quite an interesting way to look at it. This is a brain connectivity map. I can't remember what the funk. And again, you can see that there are areas. So that really dense red area is probably something like the thalamus. And the sort of loop backs. But again, there's no hierarchy in that network, is there? Yeah, more involved. So that's why they call it. It's not the boss necessarily, but it is. It's integral. But maybe some of those peripheral ones are quite integral as well. They're just more. Maybe they're the introverts. I'm looking at Philippa to see if she laughs at me. Okay. So because memory and context are so connected, let's do this. We'll do this after the break. Do we mind? How many more slides are there, Jenny? Oh, we'll do this after the break. You can think about this because it's 1:45. So we'll come back. We don't need such a long break, so we can come back 1:30. Oh, you need a long break.